Hello and welcome to my presentation on cross-curricular links in maths and science in primary education. During this presentation, I will be discussing the use of a cross-curricular teaching approach in comparison to the use of a discrete teaching approach with an emphasis on maths and science. Hayes 2010 said that cross-curricular teaching can be defined as a method which combines two or more subjects as part of a related topic or theme in order to teach them alongside each other. Barlow and Brooke in Rowley 2009 state that cross-curricular teaching uses one theme which provides a wide range of opportunities for good quality learning experiences in a variety of subject areas. We can note from several definitions of cross-curricular teaching that this method uses a theme or a topic to interlink subjects together, where the pupils can apply skills that they already have to a real-life topic or situation and create a deeper understanding of these skills. They also have the opportunity to be able to develop new skills within the subjects. What is the discrete approach to teaching? The discrete approach to teaching is to teach subjects such as literacy and numeracy without crossing into other subjects. They are taught in isolation and are not connected to other subjects. This was a popular approach to teaching as it helped to give an emphasis on literacy and numeracy, which is still very important today as the pupils are assessed on these subjects in their SATs. So how have approaches to teaching changed throughout the years? We begin with the Plowden Report of 1967. This report supported the cross-curricular approach to teaching as it argued that knowledge does not fall into neatly separated compartments. It encouraged active learning and encouraged the children to practice their skills they have learnt in order to consolidate their knowledge. However, one must note that the Plowden report did recognise that some discrete teaching would be useful for some stages of primary school. In 1987, a national curriculum was introduced and education began to move away from the Plowden ideal, and the government were given more control over what was to be taught. This resulted in more discrete subject teaching and less cross-curricular teaching. This was further supported by the Three Wise Men report of 1992 by Alexander, Woodhead and Rose. This report encouraged the discrete approach to teaching as it criticised poorly planned thematic work in schools. This approach has been argued to be easier to plan and can be used well to identify progress as each lesson objective is clear. However, one could argue that if the lessons were well planned, including the assessment of each lesson, then a cross-curricular approach to teaching could be as equally beneficial as discrete teaching. In 2003, the Department of Education introduced Excellence and Enjoyment, a strategy for primary schools, which encouraged teachers to become more innovative and creative and to use integrated teaching pedagogies when they were teaching the subject content. The hope was to develop schools where high standards in assessment were achieved through a varied curriculum, helping pupils to develop in a multitude of ways. However, according to Benson in 2004, some teachers were reluctant to make this change for numerous reasons, such as they did not have enough training or support to teach in a beneficial cross-curricular manner, and there were still high expectations of the assessment of the core subjects, and so they wanted to focus on these subjects. Since the Three Wise Men report, Rose has recently changed his attitude towards cross-curricular learning. The interim report by Rose in 2009 argues that we should have a new design for the curriculum which promotes the use of challenging subject teaching alongside challenging cross-curricular teaching. To ensure that the quality of subject teaching and cross-curricular teaching is not diminished, Rose proposes that there should be 6 areas of learning to give schools the optimum flexibility for teaching content discretely and for allowing quality cross-curricular studies to be planned and undertaken. However, although Rose's points are valid and innovative, we must remember that he cannot change the way children are assessed in English and mathematics in school. Conversely to his innovative ideas, he still agrees that due to the testing in schools, the teaching of literacy and mathematics must continue to be prioritised. This may result in cross-curricular teaching not being prioritised, as not all skills for English and mathematics can be taught through or in conjunction with other subjects. We now have the National Curriculum of 2014, which requires teachers to develop pupils' competence in numeracy and mathematics, language and literacy across the school curriculum. So what does the National Curriculum require teachers to teach? Throughout Key Stage 1 and 2, teachers are required to teach and develop a variety of math skills. They are required to build on these skills and develop deeper understanding and mastery of each of these skills. Teachers must enable pupils to apply these mathematical skills over the whole of the curriculum when they are needed. So how does this fit into teaching maths and science in a cross-curricular manner? As we can see from this diagram, a lot of these skills are used in both maths and science, and therefore, if the lessons are planned well and have a good structure, we can link these subjects through science. We can use science as a vehicle or a real-life situation where children can apply these mathematical skills. So why should we link maths and science together? We need to have mathematical abilities to enable us to carry out science experiments. For example, it would be extremely difficult for pupils to collect accurate data and analyse it to find a conclusion if they did not have the basis of data analysis used in maths first. Hiscock in 2012 also argues that math skills can be applied to science and that the two subjects should be interrelated to consolidate pupils' knowledge and skills in different contexts. Children are asked to carry out a science experiment where they are to investigate if the volume of water affects the amount of time it takes for the amount of salt to dissolve. Firstly, the children would need to use their skills of measuring in mass and volume and then time. They would then need to be able to collect data accurately and put it into a suitable graph that they can then analyse and gain a conclusion from. During this experiment, the pupils have already used their mathematical knowledge in a context, allowing them to consolidate their knowledge in an enjoyable manner. As science and maths integrate so well, especially in this example, it is important for teachers to make sure that they approach these subjects well to promote a love of learning and an enthusiasm for the subjects. So what are the pros and cons of a cross-curricular approach? Cross-curricular approaches allow for pupils to make connections between different areas of learning, and this can provide a relevant, enjoyable and challenging learning experience for the pupils, which can motivate them to learn more and pique their interest. This is very important as it is argued that it is of paramount importance that learning is enjoyable and motivating. When cross-curricular lessons are planned well and the aims of the sessions and the connections they provide are clear, one could argue that this approach of teaching gives students a stimulating context for learning which is enjoyable and relevant to them. It helps pupils to gain a deeper understanding of important ideas and theories and helps them to increase their confidence and competence in using this knowledge and these skills in transferable ways. Tina Jarvis argues that when we link maths and science together, we can see clear opportunities to enable pupils to apply and create a deeper understanding of their mathematical knowledge, especially with data handling. Jarvis also argues that giving a context to the learning helps the children to develop a clear understanding of the importance of accurate communication of mathematical data. This advantage is supported by the notions of Ofsted in their 2008 report, Understanding the Score. In this report, they discuss that children may be able to do sums, but they cannot understand what sums to do when faced with a real-life mathematical problem. This is mainly because pupils are rarely given opportunities to use and apply their mathematical knowledge and skill. However, the introduction of teaching science and maths in a cross-curricular fashion aims to improve this issue. On the other hand, when teaching in a cross-curricular manner, some of the links may become superficial and tenuous, and this stops the learning of the subjects becoming effective. In addition to this, Jarvis also argues that when teaching in a cross-curricular manner, one of the subjects could become more dominant, leading to less progression in the other subject. These points shows why it is so important to take planning into careful consideration when using a cross-curricular approach to teaching. However, this can be very time-consuming in comparison to planning when using a discrete approach to teaching. If planning is not thought out properly, there is a danger that the children may not develop essential subject-specific skills. Furthermore, it is argued that some teachers lack confidence in planning cross-curricular sessions as they have had little or no training, and this can hold back the development of using a cross-curricular approach to teaching. How can ICT be used in teaching? ICT can be beneficial to learning in the classroom, especially as children are so familiar with technology, and using ICT may increase their engagement in the lesson. One example of using ICT in the classroom is the use of data loggers, which allow children to record, present and make conclusions from data in more accurate ways that is less time-consuming. This then encourages the development of higher-order thinking skills in the pupils as they are concentrating on results given and not on drawing graphs. Using ICT in this way facilitates the cross-curricular nature of the lesson. When using ICT, children need to be made aware of e-safety, and when planning it into a lesson, teachers need to make sure ICT is used in a beneficial way rather than for convenience. As long as the children have a clear understanding of graphs and how to make them, it is easier to use ICT to create graphs for them, as it is less time consuming and the pupils can then focus on finding a conclusion, developing their higher order thinking skills. Can we benefit from using a cross-curricular approach in teaching? One could argue that with so many advantages of teaching in a cross-curricular manner, that we can try and should try to use cross-curricular approaches in teaching when suitable and when well planned. However, we could also argue that we still need some forms of discrete teaching, as children must have a good foundation of knowledge and skills before they are able to apply them. This is supported by Rose, as he argues that we should not rid our curriculum of discrete or cross-curricular teaching, as they are both beneficial to a child's learning. Rose says that schools should protect time when learning is best served by teaching subject content discreetly and systematically, and give children ample opportunities for them to apply their developing subject knowledge, skills and understanding in cross-curricular studies.